Welcome to SkyWeek. I'm Tony Flanders from Sky and Telescope magazine, and I'll be your guide to the astronomical wonders that are currently on display overhead. Let's see what's happening in the sky from Monday, April 14th to Sunday, April 20th. This week features a total lunar eclipse, one of the most amazing sights in nature. You'll have to stay up late to see it, but it's well worth it. The partial phase starts around 11 p.m. Pacific Daylight Time on Monday, which is 2 a.m. Eastern Daylight Time on Tuesday. An hour later, the moon is completely inside Earth's shadow. But instead of disappearing, it turns gorgeous shades of yellow and red due to sunlight filtering through Earth's atmosphere. The best way to understand a lunar eclipse is to imagine that you're an astronaut on the moon. People on Earth are about to see a total lunar eclipse, but you're going to see something much more spectacular, a total solar eclipse. First, one edge of the sun disappears behind Earth's disk, then more, and finally, the sun is completely hidden. Earth itself appears almost totally black, because all the sunlight is falling on the side facing away from you. However, this dark disk is surrounded by a thin ring of yellow or red light, sunlight filtering through the atmosphere from Earth's lit-up side, which is just beyond where you can see it. You don't have to guess what it looks like, because astronauts on the space station love to take photos of Earth at sunrise and sunset, when the sun is just over the horizon. The space station is up close and can only see part of the scene. From the moon, you get to see all the sunrises and sunsets taking place on Earth at that time. The light from all those sunrises and sunsets bathes you and the ground around you in a red or yellow glow. That glow is what people on Earth see during a total lunar eclipse. No two sunsets are alike. Their appearance depends on clouds, haze, and a host of other factors. And since the moon is lit by sunrises and sunsets during an eclipse, no two total lunar eclipses are the same. You never really know what to expect. There are three major factors: how deep the moon goes into Earth's shadow, the clarity of Earth's upper atmosphere, and the local weather along Earth's rim. As we've seen, the shadow isn't completely dark. Some sunlight still filters into it through the Earth's atmosphere. But it's a lot darker near the center than the edges. So, the deeper the moon goes into the shadow, the darker the eclipse. When Mount Pinatubo erupted in 1991, it threw huge amounts of crud into the upper atmosphere. That blocked light from filtering through the atmosphere. So the moon was extremely dark during its next total eclipse, in December 1992. Some scientists actually use the appearance of total lunar eclipses as a tool for studying the upper atmosphere. See skypub.com/eclipse if you're interested in helping out. As for the local weather around Earth's rim, it's really unpredictable. It can make one edge of Earth's shadow quite bright, while the other edge is dark. There's no way to tell in advance. The only things you can say for sure are that the total phase of the eclipse will be beautiful, and the moon's appearance will change constantly. Earth's shadow sweeps left to right across the moon. So, when totality starts, the left-hand edge, the part deepest in shadow, is darkest, and the right-hand edge is still quite bright. During this particular eclipse, the moon passes through the bottom half of Earth's shadow. So at mid-eclipse, the top of the moon will be dark, and the bottom edge brightest. And just before totality ends, the left-hand side will be brightest. Next week, we'll talk about the constellations of spring. Until then, this is Tony Flanders from Sky and Telescope magazine, wishing you clear skies and great views.
Brought to you by Woodland Hills Camera and Telescopes, serving stargazers since 1952.